Dear cadets, Assalamu alaikum. Welcome you all at my online class. This is Maqsudur Rahman, lecturer in chemistry, Borishal Cadet College, Borishal. Considering prevailing situation, Borishal Cadet College is providing necessary academic guidelines and short lecture on a specific link periodically. It is very necessary to keep yourself inside home along with your family members for avoiding the running pandemic COVID-19. Today, I discuss on chapter 3, stoichiometric chemistry. This is also known as quantitative chemistry. This is third session for class 12. At the end of this lesson, you will be able to define redox reaction. You can balance redox reaction by ion electron method. You can solve mathematical problems related to redox reactions. So at first, I discuss on redox reaction. In my previous lecture, I already discussed on redox reaction, though I discussed previously, but today I also discuss on redox reaction. You know that redox reaction is the combination of oxidation and reduction reactions. So what is oxidation and reduction reactions? In terms of electron transfer, oxidation is loss of electron, LEO. That means loss electron means oxidation. So loss of electron means oxidation, and reduction is gain of electron, GER, gain electron R, reduction. Gain electron means reduction. So we can say that loss electron means oxidation, gain electron means reduction. For example, when copper 2 plus react with magnesium, we get copper and magnesium 2 plus. In that case, you can see that when magnesium lost 2 electron, it formed magnesium 2 plus. In this reaction, as magnesium lost 2 electron, this is oxidation reaction, because we know that loss electron means oxidation. So as magnesium lost 2 electron and for magnesium 2 plus, this is oxidation. And when copper 2 plus accept that 2 electron for copper. So as copper 2 plus accept electron, it is reduction reactions, because we know that gain electron means reduction. And here it is noticed that when a substance lost electron, that electron must be accepted by someone. So we can say that in redox reaction, oxidation and reduction occur simultaneously. Now, balancing redox reaction by ion electron method. For your better understanding, I want to say that in ion electron method, it is also known as half reaction method. The redox equation is separated into two half equations. One is oxidation half reactions and number 2 is reduction half reactions. And each of these half reaction is balanced separately and then combined to give the balanced redox equation. So firstly, if I can separate oxidation half reaction and reduction half reactions, then by combining these two, we get balanced redox equation. So now, here is an example for your understanding. Write the balanced redox equation when ferrous sulfate is treated with acidified sulfuric acid in potassium permanganate. So by finding this reaction, we need to write the equation properly. For example, here the reactants are ferrous sulfate, sulfuric acid and potassium permanganate. So when ferrous sulfate react with potassium permanganate in presence of sulfuric acid, there are some products. So we need to write down the products properly. So at first we need to write products from the reactants. Here reactants are ferrous sulfate, sulfuric acid and potassium permanganate. So in these three substances react with each other, we get potassium sulfate, manganese sulfate, ferric sulfate and water. So we need to write these products properly. Otherwise we cannot balance redox reactions. So in second step, we need to find out the number of change of oxidation number of ions or atoms that are participated in reactants or in products. In reactants and products, you can see that in case of manganese, the oxidation number of manganese is +7, and in case of product, the oxidation number of manganese is +2. And in case of reactant, the oxidation number of iron is +2, and in case of product, the oxidation number of iron is +3. So oxidation number changes in case of iron and in case of manganese. Here you can say that manganese 7 plus converted into manganese 2 plus. That means it accepts 5 electron. As it accepts 5 electron, this is reduction reactions. And in case of Fe2 plus, it forms Fe3 plus. When it forms Fe3 plus, it donates 1 electron. As it donates 1 electron, this is oxidation reactions. Because we know that lost electron means oxidation. Now, for your better understanding, I write this equation again. Oxidation half reaction. As in our product side, we have 2 iron, so we write 2 Fe3 plus. So from 1 Fe2 plus, 1 electron is removed and form Fe3 plus. As there are 2 iron, so here 2 electrons are removed from this reaction. So as in this reaction electrons are removed, this is called oxidation reaction. Now reduction half reaction. Here manganese 7 plus form manganese 2 plus. So 5 electrons are accepted. In that case, 5 electrons are accepted. So this is reduction reactions. As there are 4 oxygen atoms, we can write 4 O2 minus, because we know that the oxidation number of oxygen is -2. We also know that in case of water molecule, there are 2 hydrogen atoms with 1 oxygen atom. So for neutralizing these 4 O2 minus, we need 8 H plus. So 4 O2 minus combined with 8 H plus form 4 H2O. And again, we know that the number of electrons donated by a substance must be equal to the accepted by someone. You can see here 2 electrons are donated, but in that case 5 electrons are accepted. So we need to balance. We need to balance electron number. That's why in step 3 we multiply oxidation half reaction with 5 and reduction half reaction by 2. Then we get oxidation half reaction 10 Fe2 plus minus 10 electron and 10 Fe3 plus. This is oxidation. And reduction half, if we multiply it by 2, we get 2 Mn7 plus 7 O4 2 minus and 10 electron, 2 Mn2 plus and 8 O2 minus. As there are 8 O2 minus, we need 16 H plus. So now if we add these 3 equations, we find out that this oxygen will cancel, this electron will cancel by this electron, and this oxygen is cancelled by this oxygen. So we find 10 Fe2 plus, 2 MnO4 minus and 16 H plus in case of product side, reactant side, and in case of product side we get 10 Fe3 plus, 2 Mn2 plus and 8 H2O. So by adding necessary spectator ions, finally we can balancing this equation, and we get 2K MnO4, that is this 2 is added with this substance, 10 ferrous sulfate, and as sulfuric acid this molecule contain 2 hydrogen, so as we have 16 H plus, if we add 8 into 2 means 16, so 8 molecule of sulfuric acid is needed here. And in case of product side, there are potassium sulfate and 10 ferric ion. As there are 2 iron atom already present here, so we can multiply it by 5. 5 into 2 equal to 10, and 2 manganese sulfate and H2O. So by this process, by ion electron method, we can balancing this chemical equation. Now another example, write the balanced redox reaction when hydrogen sulfide is treated with acidified potassium permanganate. So for this reaction, we need to write down the reaction properly. Here, when hydrogen sulfide react with potassium permanganate in presence of sulfuric acid, we get potassium sulfate, manganese sulfate, sulfur and water. In step 2, we need to find out the change of oxidation number of the atoms or ions present in reactant side and in product side. You can see that in case of potassium permanganate, the oxidation number of manganese is +7, and in case of product, oxidation number of manganese is +2. So oxidation number change here. Again, in case of sulfur, hydrogen sulfide, the oxidation number of sulfur is -2, but in case of product, the oxidation number of sulfur is 0. So we can say that here also oxidation number change. Here Mn7 plus is reduced to Mn2 plus because it accepts 5 electrons, and S2 minus, it converts into sulfur, that is oxidation number is 0. So it donate electrons. As it donate electron is oxidized, oxidation occur in this case. So now oxidation half reaction, S2 minus, it donate 2 electrons and form sulfur. As it donate 2 electron, it is oxidation reaction. Now reduction half reactions, Mn +7, it converts into Mn2 plus. So it accept 5 electron. As it accept 5 electron, it is reduction reactions. And for balancing 4 oxygen, we need 8 H plus ion. So 4 O2 minus combine with 8 H plus, and we get 4 H2O. So now we know that the number of electron is donated must be equal to the number of electron received by atoms or ion. That's why we need to multiply oxidation half reaction with 5 and reduction half reaction by 2. So multiplying equation 1 by 5, we get 5 S2 minus 10 electron and 5s. And if we multiply equation 2 by 2, we get 2 MnO4 minus 10 electron, 2 Mn2 plus 8 O2 minus, and this 8 2 minus will neutralize by 16 H plus, and we get 8 H2O. So if we add, here you can see that this 10 electron is cancelled by this 10 electron, and this 8 electron is cancelled by this 8 oxygen. So by adding, we get 5 S2 minus, 2 MnO4 minus, 16 H plus, 5s, 2 Mn2 plus, and 8 H2O. So by adding necessary spectator ion, we get 2K MnO4. This is 2. This is for 2. 5 H2S, as there are 5. 3 H2SO4. Why 3 H2SO4? Because in that case 10 hydrogen is already present in hydrogen sulfate. 5 into 2, 10. So we have raised 6 proton. That's why we add 3 here. 3 into 2, we get 6 hydrogen. In totally, we have 16 hydrogen in these 2 compounds. So in case of product, K2SO4 spectator compounds, 5s and 2 MnSO4. These 2 is come from these 2, and 8 H2O. So in this process, we can balance the redox reaction. Another example for your better understanding, that the balance redox equation when hydrogen sulfide is treated with acidified potassium dichromate. In case of potassium dichromate, we need to reaction, write write down the reaction properly. Potassium dichromate react with sulfuric acid and hydrogen sulfide. We get potassium sulfate, chromic sulfate, water, and sulfur. So like previous equation, in case of step 2, we need to find out the change of oxidation number. In case of potassium dichromate, the oxidation number of chromium is +6, and in case of product, the oxidation number of chromium is +3. So oxidation change in this case. And in case of hydrogen sulfide, the oxidation number of sulfur is -2, and oxidation number of sulfur in case of product, it is 0. So we can see that in case of chromium and in case of sulfur, oxidation number change. So as chromium +6 converts into +3, so it accept electron. As it accept electron, it is reduction, it is undergoes reduced. And in case of hydrogen sulfide, S2-, it forms S0. As it donate electron, it is oxidized or oxidation occur. Now oxidation half reaction, S2-, it donate 2 electron, it forms sulfur. And in case of reduction half reaction, it accepts 6 electron, +6 to +3. For 1 chromium, 3 electrons are accepted. As there are 2 chromium present, so we need 6 electron. And for balancing 7 O2-, we need 14 H+ and form 7 water molecule. So we have to make equal number of electrons, because the number of electron donated by some substance must be equal to the number of electron accepted by some substance. So for this, in step 3, we multiply oxidation reaction with 3 and reduction reaction by 1, and we get oxidation. We multiply it by 3, 3s2- -6 electron and 3s. And in case of reduction, we multiply it by 1. So we write down the same reaction. Now, if we add these 3 reactions or 3 equation, we find this 6 electron is cancelled by this 6 electron, and this 7 oxygen is cancelled by this 7 oxygen ion. So we can write that 3s2-, Cr2O7 2- and 14H+. In case of product side, reactant side, and in case of product side, we can write 3s, 3 sulfur, 2 Cr3+, and 7 H2O. So by adding necessary spectator ion, we get the balance equation. This is the final balance equation for this reaction. So for your better understanding, I include here another 2 examples. First one is when potassium dichromate react with potassium iodide in presence of hydrochloric acid, we get potassium chloride and chromic chloride, water, and iodine. And in case of reaction 2, sodium thiosulfate, when react with iodine, we get sodium tetrathiosulfate, sodium tetrathionate, and sodium iodide. Here I include a mathematical problem on balancing redox reaction. Question number 1. 1.5 gram of iron is dissolved in sulfuric acid and made to 100 ml. To titrate 25 of this solution, 22.5 ml of 0.02 molar potassium permanganate was required. What is the percentage amount of iron in the ore? So you can see that there are 3 substances. One is iron, sulfuric acid, another one is potassium permanganate. So at first, iron, when dissolved in sulfuric acid, we get ferrous sulfate. So iron ore, when dissolved in sulfuric acid, we get ferrous sulfate and hydrogen gas. Now, the produced ferrous sulfate is oxidized by potassium permanganate in acidic medium, that means in sulfuric acid. So the reaction is potassium permanganate, ferrous sulfate, and sulfuric acid. The products are potassium sulfate, ferric sulfate, manganese sulfate, and water. After writing this chemical reaction, we need to balance it. I already discussed about the balancing of this reaction. So after balancing this reaction, you can find that we need to find out the amount of iron by using potassium permanganate. Here you can see that there is a relation between potassium permanganate and iron. That means in ferrous sulfate. In this reaction, you can see that 2 mole potassium permanganate react with 10 mole ferrous sulfate. I say again that 2 mole potassium permanganate react with 10 mole ferrous sulfate. So according to this equation, I write it 2 mole potassium permanganate equals to 10 mole ferrous sulfate. We also write this 10 mole Fe2 plus. For your better understanding, I add question here and also repeat this 2 mole potassium permanganate equals to 10 mole ferrous sulfate or 10 mole Fe2 plus. Now, what does it mean by 2 mole potassium permanganate? 2 mole potassium permanganate means in 1000 ml, 2 molar potassium permanganate is present. And in case of 10 mole ferrous sulfate Fe2 plus, we write it 10 into 55.85 gram iron. That as 55.85 is molecular atomic mass of iron. So by multiplying 10 by 55.85, we can convert mole from mole to gram unit. So now, as here given 22.5 ml of 0.2 molar potassium permanganate, what amount of iron we get? We get 0.125 gram Fe2 plus. So from this we can write that in 100 ml solution, total iron will be 0.502 gram iron. So here we need to find out the percentage amount of iron in the ore. That's why the percentage of iron in 1.5 gram iron ore is 33.51%. Like this process, you can find out the amount of iron, or you can find out the percentage of iron in the ore. So today we learned about redox reaction, balancing of redox reaction, and we can also solve mathematical problem related to redox reactions. So if you have any question, please write it in comment box. I have a homework for you. First one is observe the stream carefully and answer the following questions. You can see a stream I given here. 4 gram iron ore, this is type 1, and 4 gram iron ore type 2. By adding sulfuric acid, 250 ml solution be prepared in both beakers. 25 ml of each solution of beaker 1 and 2 be titrated with 25 ml 0.05 molar potassium dichromate and 20 ml 0.02 molar potassium permanganate to neutralize completely. So first question is, what is called oxidation reaction? Second one, redox reaction occurs simultaneously. Explain it. Number 3, that means C, balance the titrated redox reaction stated in beaker 1 by ion electron method. And D, which type of iron ore is more economically benefited for iron extraction in industry? Analyze mathematically. So thank you very much for your participation. I want to say you that again, you must stay at home, make your family members conscious about novel coronavirus, and continue your study and make the best use of your time. Thank you very much.